Hello everyone. Can you hear me without me talking through the microphone? Yeah? Okay. Back there? Because I will probably be waving my hands around and stuff, because that's what I do when I talk. And holding a mic, it's really difficult to do that. So, my name's Rick. I was sitting on my couch a couple of hours ago wearing my swimming trunks and thinking how wonderful it would be to wear those to this presentation. But then I thought, well, it's not the right context to be wearing swimming trunks in. So I decided to just wear these pants and not to suit up, because that would maybe be overkill. There's no suits here, I think. So I'm here to talk about context-based progressive enhancement. And as I said, well, we as humans do that constantly ourselves when we decide what to wear because the weather outside is changing, it's getting cold. It's going to get colder tomorrow, but not that cold. Or you're going on a trip, or you're making decisions on what to watch this evening. And all those decisions you make, they're all based on the context you're currently in, or the context you're about to be in. And on the web, we do nothing with that context, it seems. And Conditional.js is a framework I've built to deal with context changes of the user, and to be able to present and add certain interaction patterns to the page to make the experience of the user better. So that's me. I'm a freelance front-end dev. I also do game development, and as Paul said, I build web components or plugins that I sell online, which I hope to launch into a business, which might be a couple months or years away, but well, I'm trying. Conditional.js. I've got these logos, and these are websites or companies that are currently using Conditional.js on their web platforms. And some of these platforms are rather big. And I wanted to show you this slide to let you know that this framework is being used in production, and it's not something I'm cooking up in the basement of my home. So after this presentation, if I got your attention and you think, well, this is interesting, then you can go to the GitHub repository, download it, and implement it safely in your own project. All right. So the main point of this presentation for me is not to sell you a product or to sell you Conditional.js. I just love to get feedback on the framework itself. And even if that feedback is, Rick, you got to stop building this thing because it's pure nonsense. This whole story doesn't make sense, then please convince me of that, because then I can use the time I spend on Conditioner on other stuff. So where does this framework originated from, and why did I build it? So a couple of years ago, I was working at Mirabeau, and we were writing really big web platforms. And well, if you're writing for big web platforms, those platforms, they need to be maintainable. This is not something like a marketing campaign where, in my experience, you got to launch a site very fast, and then it will be up during the marketing campaign, and then it will be killed immediately after. With these platforms, you need to be able to come back to that code you wrote after a year and then still understand what you did. So the code needs to be anything but spaghetti code. All right, so this is what we were doing. We were writing HTML, of course. Without HTML, no website. And then we had a class to a link to Google Maps. I'll be saying Google Maps a lot during this presentation, as that is the example component I decided to build this whole thing around. So we want to enhance this link to a Google map. So if you click this link, you go to Google Maps, but we want to load the Google map on our own website, if at all possible. So back then we did it like this. So we added a class Google Map. Then we built our Google Map module, which is a self-executing function, and it exposes a Google Map class, Google Map JavaScript class to the global scope, which then can be used everywhere, which might not be the best, but it worked back then. This was around 2010, I think. And then we did this. So we embedded the Google Maps script on the page. Then the initialization started, so we fetched all the elements on the page that had the class Google Map. And then we loop over those elements and create a Google Map for each of those elements, passing the element reference to the Google Map. And then we do this for our date pickers, our tooltips, all the UI components that we were going to load on the page. So that worked, kinda. It's difficult to reuse, so you cannot take this code and then paste it in the next project, and then you'll have to make some changes. So it's really custom stuff. And then this company launched a certain phone, and we had to start writing JavaScript that maybe would only make sense in certain screen sizes. So this Google Map, it would not make sense on a small screen. It just would take up way too much real estate that would be better used with other content. So on a small screen, we just want the link to Google Maps, so people could still view the Booking.com headquarters on Google Maps, just not on the page itself. So then we'd add this if statement to determine if the window is wide enough to load all the Google Maps on the page. And then, of course, we load all the other logic as well. Below there. And that'd be all the date pickers and carousels, and they'd be infested with all of these sort of if statements for all sorts of different situations that this page might be viewed in. So our logic was starting to show cracks. This wasn't working anymore. So I decided to take a step back and take a look at the state of the web as it was back then, maybe a bit before we started to write this, and at where it was heading. So this beautiful 1024 pixel screen filled with static sites, this was our beautiful safe haven for, I think, till 2010. I think this was the web where everybody built websites on IE6 and IE7, and things were fine. Well, everybody cursed at IE6 and IE7 and IE8, but well, we got by. And there were these people online that were saying, well, websites need to be flexible. You need to use percentages because people can resize their browser window. But well, if you work in an agency and the design department, they design a website, then it's really difficult as a development department to then make that flexible because it's been designed to be static. So then this happened. So the iPhone launched, and then the iPad, and maybe some other pads. And the guys that were promoting the flexible web, they were laughing their asses off. And this was, I think, right around the time that our initialization logic started to show those cracks. And then this happened. So now there's no, like you can't use this information. You can't say, where's that iPhone, where's a tablet. It's just a bunch of pixels, and you have to accept the fact that there's all sorts of devices in here. There will be tablets, MacBooks, these things, and little nano books. I don't know what kind of products are currently on the market. But if we look back now, that IE6 time, dealing with IE6 doesn't feel so bad at all. Right? So now we've got 50 browsers and 50 Android versions, and I don't know, it's a real mayhem out there. Alright, so on top of these screen sizes, we have interaction methods. And at first, they sort of look like this. So you had touch on the mobile spectrum there on the left, and then all those other things were for big screens. And people were trying to detect touch devices or touch interaction, and then they would scale up buttons so to handle touch interaction better. But then everything just split out over and touch would be available on Windows laptops, and you could be mousing and touching the screen at the same time, all sorts of crazy ways to interact with a website. And yeah, now this was basically my conclusion. The web is an intense environment to build stuff for. And the thing that we're going to build to deal with this intensity, it will have to be really robust to cope with this. So the only way I knew to cope with that was to build something based on progressive enhancement. Because progressive enhancement basically is enhancing something from the most stable layer that we have, which is HTML, and then adding JavaScript and CSS to that until you've got your beautiful website. So if I send you guys, because I stated there, HTML works everywhere. If you just write HTML and you leave CSS and JavaScript out of it, then your website works everywhere. Once you start adding CSS and JavaScript, it breaks on certain viewports and certain devices. So you have to be careful when you add CSS and JavaScript. The reason why HTML should be at the base is that at the bottom of every website and should be used and then should be enhanced is that if I be visiting secretly now, I'm visiting a website with kittens because that's what I like to see. And then if I'd share that link with you guys in the audience, then I would not know what device you would open that link on. But I'd hope that you see the same kittens that I'm currently looking at. And if that's not the case, then there's a serious problem because the web is built on this principle that you can share links, and links always result in the same base content. And that base content, that might be that link to booking.com on Google Maps, or it might be a map, but it's still the same core content. So we're going to use HTML for this framework, and then we'll enhance it with CSS and JavaScript per different viewport interaction method. So looking at that mess of viewports, we can decide that there's no way to look at device types and then determine what to do based on that. We'll have to use features to determine what we can do for this user, this specific user. And so for instance, if a user moves his mouse and the viewport is pretty wide, then we could say, well, he's probably sitting at his desk using this website. He's not on a train because mousing on a train is really cumbersome. So that tells us something about the context this user is in and how he might interact with our website. Then another thing is that functionality, that Google map that we loaded earlier if the screen was a certain width, that might not stay relevant during the entire session. So if the user is browsing a website on an iPad or something in landscape mode, and then he rotates his device, that Google Map might no longer fit, and then we need to be able to deal with that situation. We need to be able to unload the Google Map so the presentation layer and interaction layer still fits the context of that user. And then thinking about that, I noticed all these other data points that also tell us something about the context the user is in. So the current time, the light level, might be in a dark room or something. The connection stability might tell us something if he's moving, if he's having a slow connection. Battery level, if it's low, do we really want to load this super awesome WebGL animation that will drain his battery in 2 seconds? So this data will help us on top of the other data to better determine the user's context. And then, so those are the other context parameters so I've got some in this slide, but I bet there are more. So I think what we've been doing is that we've been treating every user as if they're still sitting at a desk, whether they're holding an iPhone or an iPad or an Android device or a Windows phone or a watch that somehow can be used to browse the internet. We're still in our minds placing that visitor sitting at a desk and using his device like this. And I think that is because that is classically how everybody used the internet. But people can they can be in a car, on a bus, they can be running, they can be late, and all that information, all those context parameters, they tell us something about what that person is currently doing and how we can help him to achieve his task to achieve his task better. So I've said the word context a million times by now. So what is that thing, context, and how does it relate to features? So if we look at features, then we could say the features are stable and context is ever-changing. So a feature detection using Modernizer, for instance, we could say this browser supports cookies. We can use the cookie API to place cookies in this browser. But if we look at context, that might mean this user accepts cookies. So that's a different thing. And then there might be, so we've got a way to detect if there's if the geolocation API is available. That would be feature detection. And then if we choose context monitoring, we'd be able to determine what is the speed of the current user, and is that changing, or where is he currently? Is he heading home, or is he moving away from his home? Stuff like that. So context is about change, and features, they're stable. If we detect a feature at page load, then we know that that feature will be available for the entire session, unless somebody nullifies it with JavaScript, which would be ridiculous, of course. So we detect features, and then we render the view, and then we're done. This is basically what we're doing, I think, as far as I know. Please correct me if I'm wrong. So when we start monitoring context, we can do this. So we still detect our features. We might have a mustard cut in there to determine if we should load, if we can load JavaScript, or if this is a really old browser. And then we render the view, and we start monitoring the context the user is in. Then that user, of course, gets the annoying European Union allow cookies pop-up, and he of course says yes because he's sick of all those pop-ups. And then we know we can load all of JavaScript to track this user, because all that JavaScript is dependent on cookies being allowed. So then he sits down on the couch and he rotates his viewport, and now our mega drop-down no longer fits on the screen, so we need to unload it. And then he scrolls on the page and taps some buttons, and we know he's tapped a couple of buttons multiple times, and because of that we can now say this user is probably familiar with this interface, and we can start doing a thing called progressive reduction. We can remove help texts, for instance, or remove additional labels to make more room for actually doing something on the website. So remove clutter and give the user more focus on the task at hand. Then he scrolls down, and that tells us something, and on and on and on. So this list never ends. So it doesn't fit on the slide, of course, but it'll be going on constantly. So this is basically the outline of what this framework should do. So the framework should measure the user's context and fine-tune the interface to fit it perfectly at any moment in time. So with that said, let's do a demo. I practiced this one time, so I hope this is going to be a success. Yes. This is one of my products, which I am using as a guinea pig to test conditioner in, or to do some interesting stuff with conditioner. So basically, Slim is a cropping tool to crop images in certain aspect ratios and then upload them to the server. Because this is a product page, there will be 20 or 30 of those croppers on the page. If I'd load them all at page load, that would seriously strain the CPU. So using conditioner, I can load them the moment they scroll into view. So the CPU load will be lower on page load, and then will be smeared out over the rest of the session. So if you scroll down, then suddenly, so this is a cropper, but you don't know because it doesn't show an image at the moment. But this one loads, So, and now this one loads. And what conditioner in this case does is it just detects if the element is in view, and then it loads logic. And I'll go into this, of course, further down the line in this presentation. I'll show you how this works and how to do it yourself. But for the sake of this demo, I'll move on. So it's loading all sorts of modules. There's lots of information on this page. And then at the bottom here, there's a way to stay up to date on new releases and products. Amazing. Subscribe to my newsletter. But of course, if I put this down here because I don't want to annoy any visitor with pop-ups and stuff, as long as they don't have read the entire page. So that's why it's there. But now if I start a new session, now it's down here. So conditioner now detects that this is a returning visitor, and now I position the newsletter subscription bar at the bottom of the screen, because now this user might just have bought the product and he might be in a certain mindset to stay up to date, wanting to subscribe to this thing. This is just an assumption of me, of course. I am no marketeer. And then what I also do is that conditioner measures the size of the screen, and then we only load this module if the screen is big enough, because there's nothing more annoying than a sticky footer that just takes up a big part of the screen. Alright, then this developer, he's reading this documentation, and he thinks, well, I've grown a bit tired and I will go to bed now. So he turns off the light, and then conditioner loads an inverted style sheet so the eyes are less strained and he can still comfortably read the information on the page. This currently works only on Firefox and MacBooks and stuff, but well, it's still nice, right? So, and now the light level increases and the other style sheet is loaded. Alright, so that's basically a couple ways conditioner is being used on this product page. Back to the presentation. Can I do that? Yes, we can. So, how does this work? 3 principles. 1, modules are isolated. In the earlier code examples, the self-executing module thing I showed earlier, then modules could be making use of each other without that being explicitly declared, because all those modules were exposed on the global scope of the document. Everybody could talk to each other, and modifying one module could then inadvertently cause problems in another. So we want to separate all modules so they all live in their nice little containers, and that way we can, it's easier for us to maintain all these individual modules and come back to this project in a year and still understand what this thing does. So that would look like this. So we have a define statement. This is AMD, the AMD spec. Is everyone familiar with the AMD spec? Async module definition. So it looks a lot like the self-executing function, but instead of the var Google Map at the top, it now has a define statement, which means that this function now is loaded in probably require ES, and it stays inside require ES, and it doesn't pollute the global scope. If you're into ES6, then you can also write ES6 modules, and conditioner can deal with those as well. But you'll probably have to use system.js to load these modules. Now we are dropping classes. We're going to use data attributes to bind our logic to the DOM, which looks like this. So we've got the data module attribute, and we tell it, we basically give it the module name, and then conditioner takes it from there with basically this loop. It's a little bit more complex than this, but setting up this loop, you only need one loop to load everything on the page. So we use the query selector all method to get all the elements on the page that contain a data module attribute. So that would be the carousels, the date papers, the tooltips, They would then all be in the elements array. Then we loop over the array. We get the name attribute, the path to the module from the data module attribute. And then we require it, which means we request that module from the module loader. And then when it's received, this function is called, and it gets past the constructor of the Google Map in this case. And we call new, Google Map, new module, because of course these can be all sorts of things. And then we pass the element, and then we're done. And all logic on the page loads. So now this is great, but now we still have the problem that when a viewport changes width, we want to unload some functionality and we want to load some other functionality. And what's also important is that these modules, they need to be environment agnostic. That's what I wrote here. So suppose you've got that Google Map, and that Google Map itself, it shouldn't know if it's running on a landing page or in some sidebar. If it knows about that stuff, then suddenly you can't move that module to another project because the setup will be different there. So it needs not to be concerned with its location on the page. So we need to set up functionality that monitors the context. So that's what I've done. And I've built these context monitor modules. So we've got a window monitor which monitors the window size. Then there's an element monitor that you can use to determine the size, or to monitor the size of an element, the height and the width. But can also be used, which you saw in the demo, to determine if an element is visible or not to the user, which is then useful to decide you might want to load functionality only if it scrolls in view. Then we got the media monitor, which is used to basically an abstraction over match media, which can use to match media queries, just like in CSS. And then there's the pointer monitor that you can use to determine if the user is using a mouse and if the mouse pointer is near a certain element. So suppose you've got some control to zoom in on a product, so to look at the fine details, then you might want to load that logic only if the mouse is near the element, because otherwise the user would not have interacted with that control and we would be wasting data and CPU cycles. So we need to supply the context parameters to conditioner using another data attribute, which in this case is data conditions. So the data conditions attribute now tells conditioner when to load what module. In this case, load the Google Map when the screen is at least 40 EMs wide. So this is what basically happens. We before the semicolon we have the name of the monitor, and the monitor is a module in itself, so it then requires that monitor to be used on the page. And then we have the expected value, which the monitor then watches out for if it matches or not, and based on the outcome of that calculation, the conditioner can then load the module or unload it. The cool part is that because monitors are modules, you can build your own and then grow a giant library of all sorts of scary monitors to watch your users and know what they're doing. In this case, this is the device light monitor I built for the demo you just saw. So this monitors the light level in the room, and it's basically a trigger, the event that is triggered on the window when the light level changes. And then we have the test that you can use in the data condition attribute, where we compare the received level with the expected level. And then we could do this, only load a Google Map if the user is in the dark, which might not be very useful, but is a possibility. This is also very powerful, of course. You can combine these monitors with and, not, and, or statements. And then you can add parentheses. So basically you can create really complex conditions for to detect the user's context. So we use this. I use this in the newsletter footer, I detect that it's not the first time this user has visited the page and that the screen is a certain width, and then reload the newsletter bar. Alright, so now Conditioner is happily loading all these modules and unloading them, but we've lost our control. We can't touch them because that single loop we just saw, it just loops over the page and bam, all modules are loaded. But we often want to pass some way, some configuration parameters to a module, like an API key, to actually be able to get a Google Map. So that's why I added this. It's called options. So it's basically this. You've got your Google Map object once again, or your class, and then it has this static object called options, which define the default options for this module, which is the zoom level is 10, the type is map, and of course there's no default API key, because that would severely impact the possibilities of sharing this module with someone else. Then we tell Conditioner when it initializes, we tell it that if you load a Google Map, you need to override the key parameter with this specific key. And then if we want to modify a specific option on a specific Google Map on the page, we can do it like this. We use the data options attribute and we tell it we want the type parameter to be set to terrain. And then Conditioner merges this all together, so it uses the base options, replaces the key, replaces the terrain, and then it calls the constructor. And then the Google Map has all the information it needs to render itself to the page. So as a developer, what does this give me? Some development advantage, of course. So you can now reside in this part of the slide. Sounds of the ocean, forgetting about all this terrible madness, which is of course very nice. It takes away the context problem. So it moves the context problem to Conditioner, so you can focus on building functionality, which is lovely to do instead of all that hassle. Then, as I said earlier, modules become more portable because you've built them to be isolated, environment agnostic, and configurable. And now these modules can more easily be moved from one project to the other, which is efficient. And suppose you move them to project C without Conditioner, then those modules don't have dependencies on Conditioner, and you can still use them. So it's not wasted. You've not invested your whole life in Conditioner and now are stuck with it. Those modules are still reusable. You can now pick and choose from all the enhancements you've collected. So instead of loading them all on all devices and then loading certain enhancements, you can now load only the relevant ones, and in that way conserve on CPU cycles and data transfer, the data bundle of the user. And if your server supports HTTP2, then of course this is super lovely because there would be no performance penalty and all these modules would load in parallel to each other. On top of all those development advantages, you get context superpowers. Suppose you want to sell something, which I think people at booking.com do. Nobody likes pop-ups, but this was a thing that was on my mind. Suppose a user is returning to a certain product page, and you know that he's been returning for the third or fourth time, and he's been on that page for quite some time, and he's been scrolling and scrolling and up and down, and so you can determine that he's been reading this thing and he's probably very interested in it. And that could be a condition to maybe then show a pop-up or a more subtle message as to pull him over the line and buy that product. You can now conditionally load scripts on all these devices, so you can optimize a navigation pattern for big screens. Suppose that mega drop-down is the way to go, then you can really create a beautiful mega drop-down without having to be concerned about how that thing would even work on a mobile device. So that mega drop-down can then load on a beautiful iMac, and then on a small device you can focus on how that device how users would navigate on that device. And build a really optimized navigation a component for that situation. Yeah, you can conditionally load, of course, super heavy script like product composers and carousels and stuff like that. That can all be deferred for later, for when it's actually being used on the page. And then, lastly, there's progressive reduction. So you've got your favorites button, and after 5 times, after the user has used that button for the 5th time, then we resize the text, and then after 20 times we remove the text because we know that user knows how that button works. And then there's less noise on the page. And the user can focus better on what he is there to do. So, conditioner helps you embrace all these different models instead of fight against them, which is lovely, I think. Thank you. Any questions?
I find it very interesting, but there's a lot of monitoring going on a page.
Yeah.
How do you keep track of the performance of all these monitoring? That if you hover your mouse close to an element, you have to monitor all the elements to see if the mouse is close to one of them. How do you do that?
Yeah, there are some optimizations in of course the monitor I showed. It's really basic. So there are some structures you can pick and choose to optimize that situation, because you don't want 10 monitors attaching mouse move events. You want only one, and then split the work across a single function that determines which element is nearest. So the monitor I showed was really simple, but there are some other ways you can structure that monitor to keep an eye on performance, and on top of that, of course, if you decorate your entire page with monitors, that it's something to keep into account. That might impact performance as well. Conditioner does test if monitors are still in use. So if a module has been unloaded and that is the last module that was monitored using a certain monitor, then that monitor is also unloaded. So it cleans up after itself. Yes?
I have 2 questions.
Okay. Okay.
Yeah. No, very interesting. First one is, so let's suppose, yeah, you gave the example about the mega menu, and so in the smaller devices, the mega menu will be much simpler. It won't be like a mega menu. It will be something else.
Yeah.
So is the mega menu still in the DOM?
Well, it could be. The way I see it is that mega drop down usually has a lot of content in it, and there's a core navigation pattern there as well. So there might be a list of links to the various main pages and maybe some other pages on the website. Then that might be the base HTML from which to build the small version of this navigation, and then we can use that to build the mega drop down as well. And both, the one will be unloaded while the other one loads. Point is that you could, for instance, if that thing is really big, then you could think of a way to maybe fetch content from different pages on the site and build the mega drop down that way, instead of having all that information in the DOM already. Because you just determined that this user is on a big screen, and now we might assume, and I know that's dangerous, but we might assume that his connection is okay, and then we can use XML HTTP requests to fetch content from the different pages referenced in the mega drop down to build that thing.
Cool. Second question is, like, you mentioned about the 4 options, 4 conditions that you have. One of them is media.
Yeah.
I'm thinking about Flexbox, which is on the last call of W3C.
I'm sorry, I don't
Flexbox is.
The Flexbox, the layout.
Yeah, so you don't need the media queries.
Yeah, in a lot of situations you won't
will
need
it gonna support in future? It's on the last call of W3C now.
Yeah, but as far as I understand, Flexbox is a way to determine the layout of certain elements, but it does not have doesn't react to context changes. It's just the way a certain layout is. So there's no you've got media queries, and then there's match media, the match media API in JavaScript, which you can use to monitor a media query.
Yeah, but then your fourth option, which was the media, which is with minimum 60 that you gave the example, will might not be relevant because you are using Flexbox.
Yeah, then that might not be necessary, but you could still use media queries to, of course, target specific JavaScript functionality, load specific JavaScript functionality. Yeah, I'm all for pages with less JavaScript.
Yeah.
I'm totally in agreement. Yes. Anyone else? Yes.
First, I love the library. I think I'm going to use it. I just have a question because in my mind I cannot think of a solution. How would it be used with a full framework like Angular or especially React? Like in Angular, probably you can do custom directives or anything that will wrap conditioner.
Yeah.
But in React, what would be the best way to use conditioner with React?
Yeah, that's interesting.
Have you thought of that?
I don't know if, because React uses the DOM and the CSS just as a sort of a, well, it uses as a view renderer more than an enhancement in HTML. It uses HTML and CSS as a render method. But conditioner does have two API endpoints which you can use to test a condition. So from JavaScript you can say conditioner.is and then pass a condition, and then it will return if that is currently true. And you can add, you can monitor, manually monitor a certain condition. So you can say conditioner.on and then pass a monitor or a condition to it, and then it will call a function when that the state of that condition changes, and maybe that is something that you can use in React to trigger a re-render of a certain component, or maybe fetch another component.
Or maybe there should be like a higher order component that will just be called conditioner, and it accepts the conditions as props, and then you wrap the components that you want the conditions on with that higher order component called conditioner. That might work nice, I think.
This sounds very interesting.
That's what I want to try.
I'm all for a fork and then some, or maybe a separate library with this idea.
Yeah,
I'm very interested in that.
Yeah.
So yeah, awesome.
Sounds nice. Thanks.
How easy is it to trigger these contexts when they can't be detected? For example, I want to go to night mode with a toggle switch because my browser doesn't support that. How easy is it to make those controls so that I can just, as a user, toggle night mode or whatever other context switch it might be?
Yeah, so you mean that once condition detects that a certain that it's
suppose it detects
you
that
want to ask a user, shall we switch to night mode?
Suppose it detects that I'm in Chrome or whatever, and I don't have, and it can't tell if the light is low. Yeah. So it shows a little toggle switch somewhere that I could toggle between night and day mode.
Well, in this situation, I've added, just as with media queries, I added the supported test. So the whole statement is if the light API is supported and it's below a certain level, then go to night mode, because otherwise all browsers would switch to night mode.
Right.
So then you'd be able to use that supported condition to load a module that does this switch thing.
And then I can easily tie that switch into the night mode.
Yeah, because the night it's just a class name that is added to the HTML tag. So
simple enough.
Yeah, so that would work. Yeah.
Regarding light intensity, does the user have to give a certain permission so you can track track the light intensity, or it just works out of the box?
It works out of the box.
And is it like a certain standard, or is it like an experimental feature? Which
it's currently it works in Firefox. It's been working in Firefox, I think, for 2 years now, and I read on Mozilla docs that Edge is or that Microsoft is currently implementing it in Edge as well. I don't know what other browser vendors are doing.
And Chrome doing it as well.
I don't know.
Oh,
I don't know. Yeah, well, I hope so because it's fun to do. It gives a nice effect. That's why I added it.
There is an outstanding bug for playing.
Ah. Oh, okay. So they are working on it.
Yeah.
Awesome. Oh, cool. So, yeah. Anyone else?
Is this your first framework that you've done? And what have you learned doing it? What problems do you have?
We built another framework before Conditioner, which is currently still powering Eindhoven's Dagblad.nl and lots of Wegener local news sites. And then we found that we were only tracking view width, and we were doing it on a pixel basis, and that just that was giving us trouble because the way browsers determine the width of the screen is different. Some browsers they do incorporate the scroll bar with the width of the screen, and others don't. So you'd have these situations where you'd be in some sort of twilight zone where some functionality would not and then would load. So that's something that we learned from the previous framework, and then we switched to Conditioner. We switched to Match Media and Conditioner to better match the CSS state. Also, initially I built the conditions themselves they were objects, similar to the data options parameter, which you can also pass JSON strings in. But that was really difficult to read, of course, because you'd have all these monitors stacked below each other, and then it was really difficult to build rich expressions in that. So I decided to build an expression engine, which I hadn't done before. So there's probably some optimization still to be done in that area, which is why I'm doing this presentation as well, because that would be lovely if some of you would take the time to go over that code and maybe have some optimizations that can be implemented. Any pull request is welcome. So yes.
Last question.
Yeah, last question.
Yeah.
Maybe I missed the answer you asked before, but I'm thinking of combining this with Redux, for example.
Yeah.
That you have a pure programmatically API for Conditioner and feed that information into Redux, so a whole state can change.
Yeah.
Is that something? Is that possible that you use it purely programmatically instead of going through the DOM and have configuration there?
I just talked about this. It has two endpoints to do this, so which you can use to basically do the condition monitoring, and then I think the rest is Redux and React.
Yeah.
So you guys should talk.
Thank you very much.